Assalamu alaikum and very good evening, doctor. Our group assignment here based on the hospital management system are here our 4 members of the group assignment. As you can see, we have the application purpose and accessibility and GitHub link based on the HMS application as a Python Django framework. And the purpose of this application is give some facility to the doctor, patient, and appointment and downloading and receiving the billing. And is open source application is available on GitHub, and we have 3 main role for this application and related functionality: the admin role, doctor role, and patient role. And we have some functionality and some functionality based on the user management, based on the doctor management and patient management, regarding the admin and the appointment management, billing and invoicing, and the doctor activity and functionality based on the patient access, appointment management, like accept, manage, delete, and those functionality in this application. And the patient also is doctor interaction, account and admission and appointment booking, and also billing and invoicing download. When we run this application, the first pages appear based on the local host is the login type of the login user as admin or doctor or patient. So here is the admin access. Then you can see that the first page is, comes up is the number of the doctor and the number of the patient and the total appointment, record information. And the second slide is about the doctor dashboard, that the doctor, when is logging, you can see the appointments and the patient under his or her name, and those patient is discharged. And also for the patient, some information in the dashboard regarding the doctor information, the type of the diagnosis that they have, and the doctor name and contact number. The patient also can describe their feeling and their sickness and the problem, and choose the right doctor and book for that doctor. And also in the admin page, as you can see, the appointment list is clearly expressing the doctor name, the patient name, and the description of about these people and this appointment, and some time and date. For the admin page, another facility that admin can have and functionality based on the patient record, and actually the admit the patient and approve patient and discharge patient clearly. And for the doctor parts, admin can see the doctor records and the registered doctor or approved doctor, and also doctor specialist and other information. So objective of this security testing is why, because we going the goal of this security testing is to conduct a comprehensive security assessment to identify vulnerability and record improvement. And the 3 main reasons behind this, to make because this application is collecting and recording all sensitive information regarding the patient and doctors, and it is very important to make sure this security and database is keeping safe regarding by attack and detect by the cyber attacks and hackers. And the security weakness of this application might bring lots of the disaster and dangerous activity like finance fraud and data breaches and others. For the security assessment methodology, we have 2 approaches: the manual security inspections and automated security testing. And what we are looking for, to make sure the password is secure and attackers can access to the database, and the time that this patient or doctor is using this application, this session is secure enough and safe enough for this during their activity, even they are not active. And For the manual testing approach, we have a goal for this activity that the goal of this activity is identify security vulnerability through the code review and functional testing. And the methodology we use: check the access permissions, verify the session management, and inspect the password string enforcement, and examine the input validation to detect SQL injection and cross-site scripting and common injection risk. So as you can see here is the
Okay, so now let's look at the testing of vulnerabilities within the hospital management system using the ZAP tool. Firstly, we will download and install the ZAP tool, then we will make sure that the hospital management system is fully running and everything is functional within that system. Then we will configure the proxy server for ZAP. Here our hospital management application will run on localhost port number 8000, and our proxy server will run on localhost port 8080. So basically ZAP will be using the proxy server to interact with our hospital management application. And after that, we are going to initiate the manual explore mode within ZAP using heads-up display using the Firefox browser. And then we will make use of ASAX, which basically scans all the URLs available within our application server, so that we can use that for testing. Then we will initiate the active scan, which will test the application for various, like it will do the penetration testing of application for various vulnerabilities. Then we will review that, export the report, and update our code base, and do this retesting thing again and again and again until all the vulnerabilities within our application have been properly addressed. Okay, so this is the manual explore mode. So this is our URL, and you are going to use Firefox browser, and we have also enabled head-up display, right? And after that, we are going to use the ASAX tools within this application server. Our server like port number 8000 localhost, that is running our hospital management system, right? We'll start the scan, and you can see the results from this scan, right? This is all the results, the URLs the ASAX tool has identified, and this is our different application server, all the URLs over here. And after that, we are going to run the active scan, active scan in this, right? Okay, so we are going to run the active scan on the application server. After running that, you can see here that various alerts have been given to us. There are a total of 14 alerts. One is the high risk alert, other is medium risk and low risk, and also informational alert. For example, high risk alert regarding SQL injection, the possibility of SQL injection within the admin login page of our application has been shown here. Okay, so these are the different kinds of penetration testing that the tool does within the application. So for example, checking for any kind of SQL injection or cross-site scripting or various other kind of attacks are done within the application, and if it is possible, then it will report it to us and give us all the necessary details so that we can mitigate all those issues within our code base. And when we retest it again, then it will verify that all those vulnerabilities or lapses within the security mechanism has been addressed. So basically, so this is the result of our initial testing. Various kinds of alerts have been generated. The highest one is obviously the SQL injection, which has only been found within our admin login page. So this is of the highest risks. And other medium risks are like content security policy header not set, and exposing the cookies, the session IDs, and all that has been shown over here. We'll discuss this in detail later. So this is the initial testing report. So this is the main or highest level of vulnerability within our application that ZAP has found out. Since no proper input validation or control mechanism was used within the admin login page, it is open for or vulnerable to the SQL injection attack. Here ZAP has identified the exact way this attack can take place. For example, suppose if we insert this SQL query, this long SQL query within the username or the password field in our admin page, it will generate or insert a huge blob or binary large object data within our database, which can alter the response time of our database. So it can alter the response time of the database for different queries. For example, if we log in using our normal admin password, which is processor103, this is the response time, and due to this query, you can see that during 2 times the response times are different. So this is how it can affect our application. So as we can see that hackers, while doing this kind of SQL injection attack, hackers can log in as admin, also can log in as admin into a system without having the proper credentials, which is a huge risk because we will have sensitive patient data and doctor data and medical records that can be tampered with or stolen, and that will have very much bad consequences both for the hospital as well as for the patients. So now let's look into the middle alert one, right? So when our application is being used, the users will send in requests and our application will send out responses. And within those responses, what ZAP found is that there is missing content security policy specification within the response headers. So if in this case, then attackers can inject malicious JavaScript in code into our hospital pages, leading to more data theft, phishing attacks. So it will makes our system more vulnerable because we don't explicitly specify this policy within our response headers. So within any normal web application, there is one configuration where the cookies are only accessible if we are using the proper HTTP protocol. So this setting, the ZAP has found out that this setting is not present or has not been properly configured within our application. So if an attacker injects malicious JavaScript code into a vulnerable page within our application, they could steal that cookies, and then they can do a thing called session hijacking. So they can impersonate as our original users, and our system will not be able to know, and they can gain unauthorized access, and they can steal data, change data, and it can have a lot of bad repercussions for our system. So let's look at the another low-level alert, which is the cross-domain JavaScript source file inclusion alert. So basically in our application, for example, for styling, we are going to use Bootstrap, and for the other functionalities, as you can see here, we are going to use external scripts that have been stored in other places that we'll refer to. So if there is any compromisation within there, or if those external scripts are compromised by the attackers, then they will be able to basically run malicious code within our application as well. So it will hamper our application's integrity as well as confidentiality of the data that is within our application. So this is also another alert. This is not that common, but it is a possibility. So ZAP has made it as a low-level alert. Okay, the next issue that ZAP has figured out about our application is that our server leaks version information via the HTTP response headers that our application sends back to the user. So the server basically includes version information in the HTTP response headers. So attackers can scan these HTTP headers to identify the version of our server, and using this information, they can do any specific vulnerability analysis or specific kind of attacks that have been previously done within that version or that type of a server. So this is also a possibility, though not that common, but it is also a possibility. So ZAP has also put this in the low alert level category. So ZAP has also found another low level alert for our system, which is the X content type options header missing. So basically in our response header from our server, HTTP response headers, this configuration, the X type options to no sniff, is not set or not mentioned. So without this header, or without a specific configuration within our header, browser may sniff or basically gauge this is the data type of the file. For example, if you are uploading an image, then there will be a certain data type, and text another kind of data type. So if you not explicitly mention that within the response HTTP response, then this can lead to execution of malicious content, as the whole data type is misinterpreted, or it is like openly bounded, so any data type is acceptable within our server. So this makes us quite vulnerable, and so this is why it's a low level alert. So this is the last category of alert that ZAP has shown for our application. So basically this is more informational rather than alerting, but over here we can see that it has identified that our endpoints, like for inserting username or password, for example, in the admin page or customer login page, like patient login page, doctor login page, has not used captcha. So like automated scripts or code can directly access and insert those values. So that could be one vulnerability, right? And the 3 places, so basically 3 login pages: doctor login page, patient login page, and admin login page, right? And another thing about this is, when we were writing the application, or whoever wrote the application, there is a lot of comments within the code, like for describing every single function, like this is how it's done. So it's all there, and they have not removed all those comments. So possibly if the attacker has access to our source code, then they will know how our system works, so it will be more vulnerable, and they can find out many ways to attack our system. And another thing is about the inclusion of CRS token and session ID within the response header. So if you give this openly to within all the responses, then it will be vulnerable, because they can use this within any kind of attack that will compromise the security of our system.
Hi everyone. Today I want to talk about the security vulnerabilities we found in our hospital management system and how we addressing them. Confidentiality in the application, cookies like server's token and the scenario don't have the HTTP owning and secure flags. That makes it easy for them to be stolen in as XSS attacks. Attacker can inject bad JavaScript to read these cookies and then hijack user accounts and do unauthorized access. To stop this kind of attack, we should make sure all the sensitive cookies have HTTP only, set to stop JavaScript from accessing them, and use the secret flag to make sure cookies are only sent over HTTPS. And about the integrity, SQL injection and not having content security policy are the main problem that threaten data integrity. Attackers can get around authentication, change or steal data through SQL injection. For example, they can use or 1 equal to 1 to get past login verification. Also, not having CSP-less attackers inject bad JavaScript that might cause the website content to be changed or use credentials to be stolen. Ways to defend against this include using parameterized queries to stop SQL injection, and stealing and setting up CSP to limit where scripts come from, and stop bad code from running. And for the next availability, applications depends on external JavaScript resources like jQuery from Google CDN. If this resource aren't available or get messed with, it might make the application crash or run bad codes. Attackers can take over this resource and inject bad scripts to all the visitors that affect how available and safe the system is. To lower this risk, it is suggested to use local hosted JavaScript resource as much as possible, and set up sub-resource integrity. checks to make sure the integrity of external resource.
So now let's look towards the mitigation strategies or the solutions of how we can overcome all those vulnerabilities within our application that has been identified by ZAP. So if we start here from the SQL injection, that is like the highest level of alert that ZAP had shown us. So over here, what the system does specifically within the admin login page is that it allows unsanitized input, or it allows direct input of SQL queries within the like username and password fields. So what we are going to do to overcome the vulnerabilities from that is we are, instead of using our normal approach, we are going to use the Django's ORM object relational mapping. So the input is mapped to an object, and we, based on that object, then is mapped to our database. So the direct insertion of query, direct execution of query within our code is omitted, and so we can prevent this issue. So this will prevent unauthorized access of admin access, or like others cannot access without admin credentials, and also it minimizes risks of SQL attacks. So if you see here, so now let's look at how we overcame this SQL injection issue. Over here you can see the original code. So in the original code we took username and password from the post request -gps method, right? So directly from the admin form. Then we constructed a query within the code itself, and we executed that query directly within our database. So what was the issue here was that if attacker passes on some SQL code or some regex code or leaves it blank over here, then our query is also altered, and it can give out sensitive information about the structure of our database, the contents of our database, and all other things like that. So it makes our system highly vulnerable. So to overcome that, what we have done is that we have used the object relational mapping technique that is by default available within Django. So we imported the library, we took in the values like username and password similar to here, then we created a user object, and here you can see we are authenticating the request, the username and the password, and if the username and password is not according to the current standards or format, or if there is long format, or if it's empty, then we send out invalid username and password, and if it's not none, not empty, or it's secure enough, then only we put the login request, and after putting this login request, then this user request and this user object is sent to the database with the username and password that is associated with this object is taken out, and the query is executed over there. So making this process a whole lot safer for our application. So another issue was about the missing content security header policy within the response headers, right? So what we did here, as in Django, we have a library called the Django CSV library that has all the functionalities that are related to setting up this configuration. So we import that and use that. Will also be used for later. So what it basically does is that it will block like cross-site scripting attacks, and it will protect our application from phishing or potential data theft or manipulation. So now let's look at how we actually do that. So first we install the Django CSP or content security policy library through this command like pip install python package installer install Django this, right? And we add these changes or configuration within the settings.py file of our Django application. You can see here that what we have done is that over here we have explicitly mentioned some policies, right? Over here, if you can see that allow content only from the same domain, like from the applications domain, not from an external domain, allow styles from the same domain, or allow image from only from the same domain. So we have explicitly mentioned this information, right? And we have also added cap within the list of installed app, and also the middleware for this is also installed. So another issue that ZAP pointed out within our application is that our cookies are not secure, or it is accessible through attackers that can leak important information like session ID or tokens like login token and everything. So they can do session hijacking, right? And they can illegally access our system by posing as legitimate actual users and create a lot of havoc within our system. So the main issue within our application was the cookies containing these things are not marked as HTTP only or secure. The missing HTTP only this configuration allows JavaScript to directly access those cookies. So any JavaScript code written by the attackers can automatically access those cookies, and increasing the chance. This will also increase the chance of cross-site scripting. Yes. Missing secure cookies are transmitted over non-HTTPS connection, exposing them to interception by the attackers. This is all the things, right? So to fix this, we have again installed this library as previously done and made some changes within the settings.py file. So what this has done is that it has prevented cookies from being accessed by malicious JavaScript code. So further safeguarding our system and other things are mentioned here. So let's go directly to the solution. So to ensure that the user cookies that will be generated during the execution of our system are safe and are not directly accessible to any attackers, so that we do not lose this kind of information like session ID and serious token, we have done some configuration within the settings.py file in our Django application. For example, you should see this configuration session cookie HTTP only configuration, so we can only use the HTTP protocol to access this. So this is set to true, and other things are set to true to do what? To ensure that cookies cannot be accessed by any JavaScript code, right? So similarly here we have done this configuration to ensure that cookies are only transmitted or are only allowed to transmit over HTTPS protocol only. So other things that we have done here is for preventing cookies, our system cookies, from being sent in cross-site requests. We have done this, put in this, explicitly mentioned this configuration, right? And also additionally we have added a list, so allowed hosts. So this is it is only accessible from the local host. So this is also one added security measure that we have introduced within our application. Okay, so I think this is going to be quite long. Okay, so as I have mentioned before, we are using external scripts like jQuery or Bootstrap for different functionality within our application, or for styling our web pages, right? Automatically style our web pages. So if the attackers compromise those scripts, then automatically they can inject malicious code within our application. So that will also hamper our application, and it will be a huge risk for us. So to mitigate this, what we have done is that instead of using or referring to those external scripts, we downloaded the scripts from the secure places, from the original trusted places, and we are running them locally, so that the attackers, if they even change the original code hosted in that centralized environment, our system is not affected, because we are accessing those scripts that we have already downloaded before locally. So this is what we have done, right? So this will eliminate all this kind of issues. So after downloading those scripts from trusted sources and placing them within our project directory, then what we have done is that we have updated all the HTML tags within various places of our hospital management system. For example, before, if you can see that we are directly referencing, the script is directly being pulled from this external place, right? This is also from external source. And what we have done now is that the script is being utilized from the static, what the static means, like within our local directory. So it is already stored within our local directory, and we are accessing it locally. So this will help us overcome this vulnerability. So if you remember earlier, we said about the lack of configuration, about what kind of data types can the system take or give, right? So this is related to that. So here specifically we mentioned that there is the X content type option, like the non-sniffing option was not manually configured within our application. That can lead to possible execution of malicious contents that is disguised as normal content, right? So this was a vulnerability. It was a low level vulnerability, but it was a vulnerability, right? So what we did is that we added the header in Django by updating in this settings.py. So what we basically did is that within the settings of .py file that I mentioned earlier during the other pages, we added this line. So secure content time non-sniffing equals to true. So if we redo this, then this whole issue will be mitigated, right? So the another issue that was flagged by ZAP was inclusion of sensitive information within the comment in between the codes, right? So for example, in the code, you can see the secret key is openly mentioned. So if you mention like the secret key or the API key, and we put the comment over here that okay, this is the secret key or this is that, then it can compromise our application, because if attackers can get access to our source codes, which normally they easily can, right, then this whole thing will be compromised. So our best practice should be to do not write comment about the sensitive things, and also do not explicitly mention all those sensitive information within the code in order to further protect our application from unauthorized access or tampering. So after doing all the updates within our code base to mitigate all those issues that I've shown before, we again retest our application using ZAP and generate a report of that for further analysis and documentation. So this is the report generation option within ZAP that is typically done after completing the automatic test, right? So now if you see the result of the test we did again after mitigating all those issues, we can see that high level risks has been reduced to zero. There are no medium level risks or even low level risks, but there are some informational risks. Well, this is more of like a disclosure or informational, so it doesn't affect our security status that much. But yes, we should also mitigate this, but for this project we only focused on high, medium and low level risks. So after doing all those updates, this has been mitigated, and this is the proof of that. And also, this is the screen after testing. So this shows all the results for the after rerunning the test. So you can see only the informational alerts are there, and there are no high level or medium level alerts for our application.
I will have a conclusion for our presentation. Our assessment shows that the HMAs is not ready for release due to several security failures. First, use data is at risk, as sensitive maintenance records can be exported. Second, the system fails to follow OWASP best practice, making security headers input validation and seasons controls. Third, it is highly valuable to attacks, including SQL injection, execution against, and taking data breach. Releasing an issue system could damage the hospital reputation and comprehensive printiness. The root cause of these vulnerabilities, including poor security configurations, over-reliance on unverified third-party security, a lack of security awareness among developers, and weak service setting that expose system deadline to attacks. To address this issue, we recommend several key improvements. First, improve security coding practice by using the Django ORM instead of raw SQL queries and synchronizing all users improved to prevent attacks. Second, enhance accurate actions and season security by requiring complete passwords. Enabling season expression and secure cookies with poor attribution. Third, harden several configurations by adding security headers, adding serial visions information, and strong extend spreads locally to prevent supply chain attacks. Finally, train developers on security best practice and conduct regular security audits and continuation testing to ensure optimal protection. It is important to reminder that security is a continuous process, not a one-time fix. Before the HMAs can be released, all critical variables must be adjusted to ensure the safety and printing data and the system functions. Implementing diverse scopes, approach that integrates security into software development lifestyle, can help maintain security over time. Additionally, continuous security monitoring and regarding vulnerabilities assessments will be necessary to protect the system against evolving cyber threats. In conclusion, these security assessments highlights the importance of building a safe and reliable hospital management system. The protection of patient data and history operation should be a top priority. By improving security coding practice, strings configurations, and continuous monitor security, we can ensure the HMAS is fully security and ready for deployment. Thank you for your attention. That's all for our presentation.